Okay, so hello everyone. Today I think this is the first introductory video, and today we are going to learn about the most buzzword in the field of machine learning and AI, agentic AI systems, or let's see, I simply call it an intelligent agents. Okay, so let's start with that. What are actually agents? How we define those particular agents? So, what are agents? How the agent functions, which scenarios the agent can fail, or what are the scenarios in which agents do their work flawlessly, and how we can fine tune those particular agents. But before delving into all those kind of things, we need to get a rational understanding of what actually agent is, because I think a few months back I was trying to get this particular thing into my mind, and I have searched through the entire YouTube and or any other content resources, and I have found nothing that caters to my particular need. I get to know that how we actually define, and from the very basic, how I can build those particular agents. Now, okay. So before going more into the introductory part, let's start. In this case, what I am telling that what is particular agent is. Okay. So a very preliminary example of what an agent is, that assume that this is my environment. Now from an environment, what an agent does is perceive that what is the current condition of the environment, or what is the data that is available in the environment. Now once it perceives that particular information, it does something back to the environment through actuators, and that's how we define the agents. So if I quote unquote is that an agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. That's a very classical and a simple definition of an environment. Now, if we get to know that, if we let's understand this particular definition in a little more bit detail. Now, consider that this is my environment, and it could consist of an entire universe, or it can consist of an entire designated closed system. So, the environment could represent any of the spectrum of the of how we define a particular closed systems. Now, if we from that particular environment, if we perceives that how it what is the current condition in the environment, or what is the current condition in the environment, and through that particular current condition in the environment, that that we perceived, if an agent takes action, and that action is being given back to the environment through actuators. Now this is the entire workflow of how an agentic framework will look like. But the question arises that what is you actually meant by the current condition environment? Because if because we know that agents should have a past understanding of the entire past understanding of the data, or past understanding of the input and output data. So yes, it does not only sense that what is the current condition in the environment, it also takes into account the historical data. So in general, an agent's choice of action at any given instant can depend upon its built-in knowledge and on the entire perceived sequence. So it also depends upon not only the whatever it perceived the current condition in the environment, but also the built-in knowledge, and that built-in knowledge we have given it to the agent while training it, or through some other source or means. Okay. So it could be the entire historical data, it could be a subset of the entire data, or it could be the current condition also. Okay. So it's entire plethora of the knowledge that the agent took from the environment, and based on it, it gives a particular output sequence. Okay. So by specifying the agent's choice of action for every possible perceived sequence, so there could be n number of sequences that the agent does at every instant. And if we go through the entire perceived sequence and find out that for this particular sequence, this is my particular output. So given um, if I will get to that part, but the thing is, let's consider that the constraint here is that it can take the current condition, it can take the past condition from 0 to t, but what it cannot take, that it cannot take any of the condition in which the agent hasn't seen in the past. So it cannot take the future condition into account while giving a particular action. Okay, and that's, I think that's how the reality works. Because we cannot we can just think that what could happen in the future, but we cannot take that scenario into account and build a particular output. So it can just take the current condition as well as the past condition to give a particular output that might resemble a particular condition in the future. That's how the agent works. Okay. Okay, before going into that, how the internal framework or the external framework of the agent works, let's get to some of the terminologies. We already learned about what is a percept sequence means and what is a constraint associated with it, but we should also learn about that what is an agent function means. And now mathematically, if I talk about it, given a particular set of input percept sequence, so given a particular type of input percept sequence, what is an agent function? It maps any given percept sequence to a particular output. Here in this case, it would be an agent action. Is it? Yes. Okay, that's how we very minimally define an agent function. So given this particular agent function and given a particular set of inputs, can we build a table that for this particular input we have this particular output, for this particular input we have this particular output? Yes. So this particular table is actually represent the external characterization of the of my agent, that if you give me this particular set of input sequences, I will give you this particular set of output sequences. But the thing is, you need to understand the basic difference between two terms, the agent function and the agent program. Okay, so this particular table gives you an overall external idea that how my agent function will work, but internally the agent function for an artificial agent will be implemented by an agent program. Okay, so all these output you will receive only when an agent program execute a particular agent function for a particular input sequences. Okay, so given let's understand this. So how to look like that? So given a particular set of input and you receive a particular output, this particular agent program will execute the agent function, then only you will going to receive this particular output. So this is my agent function and this all comes under my agent program. So every time for a particular input, the agent program execute this particular agent function to get me a particular output. This is what internally happens. Okay. And let's just better understand that what does it mean, let's go to this particular classical example of what actually the entire framework of agent looks like. Now consider this vacuum cleaner, which is defined by this particular agent function, that if it lies in a particular block, here in this case we have two blocks A and B, if it lies in a particular block and if there are shards or there are certain materials which certain pieces that are available in that particular block, it will clean it, otherwise it will move to the next block. Okay, so how we can build, so this entire framework is known as the agent function, but how we can build the table out of it. So if let's say the vacuum cleaner is present in the A block and it is clean, it will move to the next opposite block. If this suppose the vacuum cleaner works lies in the A block but it has shards available in it, it will clean that particular block. So that's how the agent function will work. But to get this external characterization, all these function the agent function will get executed by the agent program. Okay, so how the agent program will look like? So it is a function that removes shards, and inside this particular agent program we have this entire agent function written out. So whenever a particular input will come, the agent program will execute my agent function, and then only we're going to receive my output. Now, the problem in this case is that here all these input sequences may or may not be artificially generated in order to get the entire external characterization of my agents. And therefore, the obvious question could be that what is the right way to fill up the table? Because it may happen that one of the case scenarios may not even happen in the reality, or there are certain sequences of the inputs through which whatever the output the agent will give me will represent a bad agent. Okay, so what is the right way to fill out the table? In other words, what we wanted to know that how we can classify that what actually is a good agent, what actually is a bad agent, what actually is an intelligent agent, and what is a stupid agent. Okay. So consider this like that you open a fridge in your household, and so the obvious rational logical thinking would be, so once you open a fridge, you will get some material inside. It could be any food item, it could be any drink, or it could be anything. But once you open that fridge and you doesn't know, and only when you perceive but once you open the fridge and once you perceives that whatever inside the fridge, and then only you are able to take a decision that what is inside the fridge, then that's how the agentic framework is look like. So it's basically like a Schrodinger's cat. Okay, so once even if you once you look into it, then you'll be able to decide that what is inside the particular fridge. Okay. So the thing is, so this all, so these were the few keywords that you might listen time to time in the case of agentic frameworks: is percepts, agent function, agent program, agent program. There are a few more keywords which I introduced in the later videos, but the thing is, if based on these three, how we can classify a particular agent or the action of a particular agent into a good, bad, intelligent, or stupid. So we will learn about this in the later section of the videos, and if you like it, then we will learn more about it.